Okay, so this is another question based on friction and loss of motion. So what I've done is I want some of you have asked for a very concise version of the solution so that you can just save time. So what I've done is I've tried to summarize my best here. Okay, so every step is written in order. So your visualization, frame of reference, you have selecting the system, the bodies. Two bodies are considered. Free body diagram of both have been drawn. Sigma fx and sigma fy of both have been drawn, and solve for unknown. Solving for unknown. Everything is written here. So if you want, you can just go through this solution. Pause. If you're watching it online, pause your video. You can go through this content. Maybe take a couple of minutes to go through this and write it down. Things will become clear to you. And if you feel that further explanation is required, you can maybe start watching the entire solution in its depth. Okay, so now we have a very simple, a very straightforward question from based on friction. A block of mass 40 kilograms slides over. What does it mean when it slides over? When the question says slides over, it means that the friction acting there is kinetic friction, or in other words, the motion acting, the process that takes place there is relative motion. So a 40 kilogram body is sliding where a mass of 4 kilogram is suspended through an inextensible massless string. The coefficient of kinetic friction is given to us as 0.02. Since this 4 kilogram body is not in contact, it will neither have normal reaction nor have friction. So we assume that the body is coming, the 40 kilogram mass is moving towards the right and the 4 kilogram mass is moving downwards. So as usual, we'll start with visualization. Frame of reference, I will choose the frame of reference to be the inertial frame of reference here. System, the two block system, two block pulley system. Isolate the body, we'll isolate both these bodies and then we'll go for sigma fx and sigma fy. So let's go one by one. So first up, 40 kilogram body is moving towards the right. 4 kilogram body is moving downwards. What are the various forces acting on it? Weight will be acting downwards. Normal reaction will be acting upwards. Tension on the string originating from the point of contact away from it. Tension of the string originating from the point of contact away from the string. And the most important force here, friction, which will act opposite to the direction of relative motion. Right? Now let's see this one by one. So for the first body, we can draw a free body diagram and arrange the various forces acting here. So tension acting in the right towards the right, weight of the body acting downwards, kinetic friction opposing the motion, and normal reaction on the 40 kilogram mass due to the surface, right? Due to the surface would be N40S. And what is the direction of motion? The net direction of motion is towards the right. Now, keeping this in mind, right? Keeping this in mind, okay, give me a second. Sorry, my bad. Now what's up? Now we'll have to apply sigma fx and sigma fy. For that, we need to find out sigma fy first and sigma fx second. So what is sigma fx equal to? Forces acting upwards is equal to forces acting downwards. Why so? Because there is no motion along the y-axis, which further implies that forces acting upwards would be equal to forces acting downwards. The force acting upwards is normal reaction. The one acting downwards is weight. Sigma fx is equal to ma. Why? Because why are we taking this ma? Because there is a sliding motion, right? Sliding motion towards right. Which means sigma fx is equal to ma, right? Sigma fx is equal to ma. What is sigma fx? Sum of all the forces acting along the x direction. So how many forces acting along x direction? We have tension and kinetic friction. How do you choose the sign? Those forces which are acting along the direction of motion, which in this case direction of motion is towards right, tension is towards right. So we'll take those forces to be what? To be positive. So tension would be taken as positive. Tension would be taken as positive. Then kinetic friction, which is acting against it, would be taken as negative, is equal to ma. So what is kinetic friction? Kinetic friction is mu k into n. What is n? N is from this equation is mg. What is mg? Mg is 40 into 10. So 40 into 10 into 0.02, what we get is 8. So I'll transpose negative 8 to the RHS. So we have t minus 40a is equal to 8. Now, if you want to understand this a bit more conceptually, so this should be ax, right? This should be ax. This should be ax. This should be ax. This should be ax, right? Okay. Now let's move on to the next body. So what's the case with the next body? The next body T, 4 kilogram, is coming downwards. So if you analyze this 4 kilogram body, there are only two forces acting on it. One, tension, that is originated from the point of contact, acting away from it. Two will be the weight of the body, right? Two will be the weight of the body acting downwards. Now, for this body, for the 4 kilogram body, sigma fx is equal to 0. Why? Why? Because this object is not moving along the x direction. There is no motion along the which axis? No motion along the y axis, which means forces acting left should be equal to forces acting right. What are the forces acting? What are the forces acting? There are no forces which are acting along the left or the right of this body. Right? There's no force acting along the left or right. Why? This is why I have written the first diagram very clearly, that there is no contact, and since there is no contact, it simply means that there will be no contact forces. However, in the case of the same body moving in the y direction, the net direction of motion is acting downwards, and there are forces acting along the y direction. Which are the forces? If we consider the free body diagram, this is the 4 kilogram mass. Weight is acting downwards. Tension is acting from the point of contact away from it. Tension is acting here. Tension is acting upwards. Weight is acting downwards. Now, what is the net direction of motion? Net direction of motion is downwards. So, how do you choose the signs? This would be positive, which means weight should be given the sign positive. Tension is acting away from it. Tension is in the opposite direction. Tension should be given negative. And then we have the equation minus t minus 4a is equal to plus 40 which is minus 40. Okay. Once we have this, we can go to solution solving this. So using two, maybe we could just enlarge it. So using two free body diagrams and the respective solutions, what do we have? We have minus t is equal to minus 40 t minus 40 is equal to 8, and we have minus t minus 4 is equal to minus 40. If I add these two equations, t minus t is 0, t minus t is 0, minus 40 minus 4 is minus 44a, 8 minus 40 is minus 32, a is equal to minus by minus is positive, 32 by 44, which is by 2 gives 16 by 22, further gives 8 by 11. So the acceleration here would be, let me just go through the question one more time. Acceleration here would be equal to, which option is that? Option D, which is